Well, I knew that everybody would be having a really good time with the idea of inverse functions. So I threw what's really a pretty easy problem in here, but with, I think, pretty good I think the problem does a pretty good job of convincing you that this inverse function thing works. So we have y equals 4x minus 3. And we're going to say that defines our function f of x. In other words, f of x is 4x minus 3. And g of x is going to be our inverse function. Now, how do we get a function inverse to a y equals 4x minus 3 function? We switch x and y. And everybody knew that. Okay, and people picked up on this very well, which is why I think, again, that the problem with test performance right now is one of lack of sufficient follow-up. Okay? If you follow up, if you go home and do the homework that's been assigned based on what you understand in class, and at least start that before you forget what we did in class, I think you're going to do quite well. Okay, so what do we get? If we reverse x and y, of course, y becomes x becomes y, we get x equals 4y minus 3. And again, everybody wrote that down correctly. I didn't have to tell them. Okay, it's very good. Okay, and then we solve that for y. Well, people did that. There were a couple of algebra errors. You know, people need to upgrade their algebra a bit. That really gets in the way. That's not a problem of follow-up. That's a problem of the courses you've had before, and you know, you're kind of on your own for upgrading that. Anyhow, y then equals x plus 3 over 4. We just solved this. I'm not going to go through the algebra steps. Add 3 to both sides. I'll go through them. I won't write them down. You add 3 to both sides, you get x plus 3. Divide by 4, you get x plus 3 over 4. And that can be written as x over 4 plus 3 over 4 if you like, or it can be left like this. It doesn't matter. It'll work out. Or you can write it as 1/4 x plus 3/4. Yeah, x over 4 is the same as 1/4 x after all. So in any form in which you write it, and you ought to work it out with every form, we then form f of g of x and g of f of x. Okay, well, f of g of x, what's that? Well, f of x is 4x minus 3, so f of g of x here, g of x has to be here, that's got to be 4g of x minus 3. Okay? And people are starting to write this down, but it doesn't look like you quite trust it yet. Trust yourself, go step by step. If it's wrong, we'll try to correct it. Now, get me the homework so I can tell if it's wrong or not, so you know. Okay, then, g of x, of course, is what? G of x is either this, or if I write it as some people did, 1/4 x plus 3/4. And any one of these forms is equally as good as any other. So there's nothing at all wrong with this. Okay? Matter of fact, I kind of like that one best. Okay, so again, 4g of x minus 3. G of x is 1/4 x plus 3/4, the form that I decided to use for this example. So we plug that in for g of x, and now we just simplify. How do we simplify this? We don't worry about common denominators and stuff, and people that made algebra errors in this usually did because they were trying to find common denominators and do stuff with common denominators. It's totally unnecessary, complicates things, and if it's not done correctly, can even lead to errors. Okay? At the least, it complicates things. At the worst, it complicates things and you do it wrong, and it doesn't work. Okay, so 4 times 1/4 x plus 3/4 minus 3. We distribute the multiplication by 4. We get 4 times 1/4 x. Then we get 4 times 3/4. Now, at this stage, of course, we have the minus 3. 4 times 1/4 x, if it's really obvious to you and you're secure with this, 4 times 1/4 x is x. And 4 times 3/4 is 3, so this is x plus 3 minus 3. And that equals x. And boom, there we are. The f of g of x is reduced down to x again. showing that these functions are inverses. Although we want to check g of f of x just to be absolutely sure. Okay? Now, if you don't understand why 4 times 1/4 x is x, if you just have some vague notion, well, the 4 somehow go away here, and maybe they go away over here too, so let's write it down and hope that they did. And that's the state in which a lot of people, unfortunately, come out of Algebra 2 courses and even our MTE courses without a very clear idea how the algebra works. So if you're in that category, let me explain a little more. 4 times 1/4 x means 4, well, you got a 4 in the numerator, you got a 4 in the denominator, so we can write that as 4 over 4. And of course you got the 1 here. Now there are other details I could go through, and maybe I should, but I don't want to go into so many details that everything gets jumbled up and lost. Okay, so 4 times 1/4 is the same as 4 times 4 over 4, which is 4 over 4. And 4 over 4 is just 1, so 4 over 4 times x is just x. You need to be able to think it through on that level. And 4 times 3/4, well, you could write that as, okay, 4 over 1 times 3 over 4. That's 4 times 3 over 4, which is the same as 4 over 4 times 3, which is 1 times 3, which is 3. I don't like cancellation. I don't like people crossing things out, because if they can't do this, they almost universally do cancellation wrong and go around believing it. So I see so much bad cancellation that I don't even use it if I can help it. And it can almost always help it. So cancellation comes about because 4 over 4 is 1. And people will do 4 plus 3 over 4, and they'll cancel the 4s, and they'll get 1 plus 3. And that's absolutely 100% wrong. 4 plus 3 is 7. This is 7/4. But 1 plus 3 is 4. It doesn't work. Cancellation is what I consider to be an obsolete shortcut that leads to a bad result. The rules for cancellation are complicated enough that people don't remember them, people don't apply them. Okay, well anyhow, that's how you justify x plus 3 minus 3, and that's equal to x. Okay, now g of f of x, what's that? G of x is 1/4 x plus 3/4, so g of f of x is 1/4 f of x plus 3/4, 1/4 f of x plus 3/4. F of x is 4x minus 3, so that we get this expression that I won't read to you, but 1/4 then of 4x minus 3 is 1/4 of 4x minus 1/4 of 3 plus 3/4. 1/4 of 4x is x, and you can go through this sort of thing to verify that for yourself. And 1/4 of 3 is 3/4, so it's going to be a minus 3/4, and then a plus 3/4. And that gives us, all that's left is x. So, voila! F of x and g of x really are inverses. In the homework, there are a number of problems where you got to invert linear functions, and a number of problems where you have to invert something a little more complicated than a linear function. And I'm not going to address that now. If you can do it for linear functions, and if you do it in the homework, then you'll probably have a pretty good idea of what to do when it's not a linear function. And I think that, with the ability I see in this class, many people will be able to do that. Now, inevitably, somebody makes a mistake, but I think people will start it out right, and if they make a mistake, it'll be easy to correct.